Hey guys, Mr. Yisley here. So we are on to lesson number 21 in chapter 4, all about writing linear functions. And the remainder of this chapter, we're going to be talking about arithmetic sequences. And so as you should have defined in your vocabulary prior to this, a sequence is really just an ordered list of numbers. So we've got a number list they've given to us, and it's ordered out. Within each one of those lists, we have the numbers are known as terms, so we've got these terms going on. But an arithmetic sequence is saying that there's a specific difference between each part of that, or it's also known as a common difference. It's the same difference between each term from one term to the other. We kind of dealt a small idea of this, was this idea of a constant rate of change that we dealt back with in chapter 3. But within arithmetic sequences, this constant rate of change is known as a common difference. And so what's happening? Are they adding 5 to every number from the number before it? Are they subtracting 3 from every number from the one before it? Like, what is going on with this? There could be multiple things kind of happening to arrive at it, but really that's what we're talking about in arithmetic sequences, is that we have a common difference between each pair of consecutive terms in this sequence. So in lesson number 21, what we're going to talk about specifically is extending an arithmetic sequence. So if they've given you a list of 3 to 4 numbers, can you figure out what's going on with them and then write the next numbers in that sequence? So in example 8, it's telling us to write the next 3 terms of the arithmetic sequence of -7, -14, -21, -28. Well, in order to be able to write the next 3 terms, I need to know what's happening from the first term to the second to the third to the fourth, so on and so forth. So what I notice is that from the first term of -7 to the second term of -14, they subtracted 7, because -7 minus 7 becomes -14. I then noticed from the second term to the third term that they again subtracted 7. And then from the third term to the fourth term, they did the same thing. They subtracted 7. So it would only make sense that from the fourth term to the fifth term, they would subtract 7, which would give me the number -35. Then from the fifth term to the sixth term, they'd subtract 7, which would give me the next number of -42. And from the sixth term to the seventh term, that would give me a number of -49. So my next 3 terms in that sequence, because all they were doing was subtracting 7 every time, became -35, -42, -49. So that's how we extend an arithmetic sequence. I'd encourage you to try example B on your own, then check your answer with mine. So example B says -12, 0, 12, and 24, and they want us to write the next 3 terms. Well, again, figure out what's going on from one term to the next. So from the first to the second, I started at -12, and now I'm at 0. Well, the only way that could happen is if they added 12, because -12 plus 12 is 0. Then from the second term to the third term, they went from 0 to 12. Well, the only way that could happen is if they added 12 again. And then from the third term to the fourth term, to get from 12 to 24, they added 12 again. So that's what's happening. So then I need to do to get my next 3 terms. So if I add 12 to 24 to get my fifth term, I get 36. To get my sixth term, 12 to 36 is 48. And to get my last term that I need, I add 12 to 48 and I get 60. So my next 3 terms in this sequence would be 36, 48, 60. All right. Well, if you have any additional questions on how to extend an arithmetic sequence, please let me know. But otherwise, you should have what you need to continue on in the chapter.